I just get going. Thank you so much for giving me an opportunity to speak. And so sorry I couldn't make it in person. So I'm going to talk about an assessment paper on high impact climate events, tipping points and irreversible regional impacts that the Lighthouse activity on safe landing climate of the World Climate Research Program has kind of stumbled into. I can talk a little bit about first why does it not let me change slide? Here. What we are doing broadly. So we have been looking, it has the safe landing climates. Lighthouse activity has several activities, and one of them is high risk. The high risk group, which Betty Otto-Bliesner and I are co-leading, and Steve Sherwood and I are leading the Lighthouse itself. And so the high risk group has been looking at cascading shocks in a workshop in November, also at economic shocks, together with a group on pathways towards a safe landing climate, and wherever we went with our high risk shocks, we touched on tipping points or on relationships to tipping points, and so we started becoming a bit more interested in that. And as one activity, we started, Betty Otto-Bliesner and I started What If MIP, which is basically a MIP for what if a tipping point is crossed, which has merged into one angle of TipMIP, which was really a good way for this project, which was motivated by the realization that a lot of the interactions that you would need for tipping in the Earth system are not available in Earth system models. At least they were not in CMIP 6 or in previous modeling exercises, and may not be easy to have in its full beauty in the next realization either. And so so this is particularly with respect to forests. So this is what motivated us. We also have a few other things in the Safe Landing Lighthouse. There's an assessment running on the total transient climate response to cumulative emissions. So basically, instead of transient climate sensitivity, transient response to emissions, linking it directly to emissions, which, for example, Pierre Friedlingstein is strongly involved in, also some people in this workshop, and also we have some activities on sea level rise and water variability and scenario exploration. So why did we think about this assessment paper? We realized that the topic of climate risks and high impact outcomes is crucial and may need more emphasis than it had in past IPCC assessments and in our research, because it falls a bit between the cracks, as it often involves interactions that the Earth system models may struggle with. The evidence for such events that are slightly broader than tipping points is a tricky combination of records of the past, so past paleoclimate, as in tipping points in a narrow sense, the various types of models, from nonlinear dynamical models to full Earth system models, and scales may not be as well resolved, as you know. And the research community is not seeing eye to eye on the evidence for and concern about tipping points. So you can see that in the discussion, for example, recently triggered again by the COP et al. Paper, but also generally has been going through the community and is also in response, it also plays out in media outreach of the community. And so we felt we need so Thomas Stocker particularly was keen on seeing a consensus building happening ahead of AR7. Thomas has been advocating for a special report on tipping points, but the governments were not particularly keen on it. Also, maybe in part because it seemed to some governments to be something about bifurcations and not so much about, for example, limits to adaptation or something like that. And so so what we're looking at is something that's a bit broader than and includes, for example, limits to adaptation. So what happened is that we had a scoping group, including some people that were initially pushing for an expert meeting, and that was then followed by nomination of section leads. And we take the papers that are out in the literature as points of departure. So Armstrong-McKay, also the Wang et al. I think paper is a nice review, and the Global Tipping Point report, of course, and the supporting scientific papers. We've also, some of us have been involved in a service in geophysics paper that came out after a workshop at ISI in Bern, where we looked at extreme events contributing to tipping elements and tipping points. And I just, that had two graphs that I want to draw your attention to. One is that the tipping points and climate are increasing in publications in the same rate as extreme events and climate. So it is, so that's not a good argument that they're connected, but I think it is definitely a good argument in favor of looking at it much more than, for example, the last IPCC assessment, which was scoped at a time when this enhanced activity wasn't yet so obvious. And I just show you one slide from Natasha, Sonia, and my paper with many co-authors, where we have just plotted which aspects of tipping elements, we took the Armstrong-McKay graphic, are linked to extreme events in terms of both noise-induced tipping, but also as mechanisms for inducing the change, and have plotted into the Armstrong-McKay paper where heat waves, extreme heat, fire, ocean heat content anomalies, extreme sea ice anomalies, drought can influence or change the probability of a tipping point. And this is maybe even more pronounced for the smaller scale tipping elements, such as the coral reefs, which are affected by extreme heat and the oxygenation and pH extremes. So when we started collating the author team for the paper, which is funded by World Climate Research Program, and of course by the author's own research projects, we are the first draft questions, which are still under improvements, are what are the processes that lead to tipping or stabilize against tipping, and are these well enough represented in Earth system models? And IMIX, what does paleoclimate evidence or other observations say about it? And can we bring these two lines of evidence together, very much along the line of what you're doing in this workshop? What climate scale, large scale events or changes can lead to severe consequences and irreversibility. So this could go a bit broader than tipping. For example, in food systems, what thresholds need to be considered for tipping impact. I'll talk to you a little bit about that in a sec. And also, what are the carbon consequences? What can we do to better enable early warning and predicting risk of tipping points and irreversibility? And maybe even give some community recommendations of how we could analyze upcoming model simulations, for example, the ones that you are doing. The publication is, we are aiming to finish this in 2026 and are so well ahead of IPCC, as the goal is starting to build a consensus, but not to have all the answers. I think it is aiming to enable the community to build on it and add to it. And so, and I'm going to go through the sections as they are in a very drafty form. In the moment, we have bullet points and authors. The author team is largely assembled, but we are still open for additions. Since nobody else volunteered, Hannah, Liddy, and I are doing definitions and scope, and I think that's actually a really important section, and we have seen it also in your meeting or in this week's meeting, that the exact definition of what falls under a tipping point and could be controversial, and is important to think about carefully. And maybe that would be also a recommendation for your project, to think about quite carefully what the different groups investigate, because different types of tipping elements would be more interesting for them. Different aspects of the definitions might be more interesting. So we have, of course, the standard definition, you know. The IPCC has broadened this a lot because it's difficult to find bifurcations in the full Earth system. So we they look at the critical thresholds beyond which a system reorganizes. And this is kind of broadened out from a definition by Tim Lenton. And then there has been the critique by Kopp et al. Say that this is so broad that it is not really useful, and recommends to bring back traits of different criteria, 3 criteria: traits of abruptness, acceleration of change, irreversibility, and feedback-driven self-amplification as 3 things that could, where tipping points could involve one, several of them, but don't have to involve all of them. And I think that's it's actually a good recommendation to characterize beyond, is this a tipping point or not, and what are we actually looking at. And we have added cascading effects and impacts of high impact events, so basically irreversible impacts. The irreversibility is, as you know, a tricky concept. This is just illustrating from Solomon et al. 2009 how unless you draw CO2 out from the atmosphere, every change that involves that is in response to CO2 is irreversible on human timescales. You could also set it against relative to the irreversible relative to the global mean temperature or the response to forcing. Then you could have an example, for example, from the Delworth et al. Paper, where the Mediterranean drying follows the AMOC and does not recover in the same way as, for example, global temperatures when you bring emissions down. So there's irreversible is a difficult concept to define, and we are still working on our definitions and would be extremely grateful for input. We have also a section on the ocean, which is led by Anastasia Romano and Thomas Fröhlicher, and has a bunch of more authors. Some of them are in this room. And examples that they are looking at, for example, is the GIS runs, where 2 model simulations tipped due to noise, due to sea ice-driven noise, and they also look at the impact of very severe compound events, such as here shown, breaching the thresholds for certain marine life forms, both in acidity and in sea surface temperatures. So they are going quite broad, looking also AMOC SPG, coral reefs, and these high impact events. Then we have a group on cryosphere that's led by Tim Nash and Ricarda Winkelmann, with a lot of co-authors. I hope I have caught them all. And they are looking at the same as you and our Greenland ice sheet, sea ice, glaciers, and impacts, mitigation and adaptation options. So where are we, and what do we need to research more? We have one on tropical land system. This is just a diagram I've pinched from the Sherwood et al. Paper on that we wrote about how to characterize climate risk, which reproduced the Tao et al. Images on a radar retrieved forest canopy, which is not only in the South American rainforest, but also in Africa and East Asia is under stress. And we look not only at tropical forests, but generally tropical ecosystems, and where there is a danger that they change in the transition to a different state, for example, a seasonally dry forest or a savanna. We have a section on the boreal land system that Victor co-leads with Annette Bartsch. I think Victor is in the audience. And that they look at the vegetation and permafrost and feedbacks on how well this is captured in ESMs, and look at both global and regional significance. And here we have also interesting evidence from warm periods. We have also some retrievals of changes in vegetation that is already ongoing with northward movement and southward retraction. The Wang et al. Paper was on a fence if boreal forest is a tipping element. Also, the satellite data show impacts of severe extreme events in regions where, for example, northward, you don't necessarily have everywhere an increase. And then, of course, permafrost is a very big topic and also important for carbon storage and the response to heat, and is and you have been talking about this as well. And maybe the most different section is the section on threshold breaching and tipping in impacts. This was one of the reasons how I got interested in the tipping point topic is from the Dust Bowl example in the Great Plains in the US, where you had a feedback-driven amplification of a drought-induced land surface change that was also strongly influenced by human choices in, for example, in growing wheat rather than having the prairie grass. So it's led by Ala Al-Kodaye and Jonathan Moyer, and has a large group of experts from different aspects of impacts. So from human health to food system, a whole lot of different things. And they look at how do physical tipping points translate into high impact consequences across human and ecological systems, something that you are doing in much more detail and much more focused, but also what climatic events lead to threshold breaching, self-accelerating, rapid or irreversible change in impacts that aren't. So these climatic events wouldn't necessarily be tipping events. And what are mitigations are available, adaptation and early warning. So this group is actually, I was very nervous about this section, but it's coming along. Their bullets look really exciting, and they're doing exactly what I hoped they would be doing. And seem to be doing it really well. And an example for the thresholds, I'm just bringing this graph from Hegerl, one of my co-workers, who looked at how dangerous heat with wet bulb temperature greater than 31 degrees emerges with warming of present time 1.5, which we pretty much have now, up to 3 degrees. And you can see that large regions of the planet will have occasional occurrences of dangerous heat waves and even deadly heat waves. I'm not showing that plot, but also that emerges where you cannot stay outside. And that is particularly severe in strong population centers such as India and Southeast Asia. And section 7 then is very closely related to what you're doing here, outstanding uncertainties and model capabilities. That's led by Betty Otto-Gleason and Torben König, and is looking at maybe your early results could be really useful here, but we are also fully aware that you need to first publish your results, but maybe we could we can connect when they are ready to be cited. And it looks also at examples of events across model hierarchies, land atmosphere vegetation processes and their limitations, and how well are the models, what is missing in coupling processes, for example, in terms of how does the boreal forest what can it represent in terms of a heat wave? It's the carbon fires that occur in response to heat waves, which seem to be, which are modeled in some ESMs, but maybe don't show the largest fires. How does this release carbon? And what is the regrowth of vegetation? What is actually the capability here, and how does it evaluate? And this overlaps, and one of the fun discussions we are having is how does this overlap with subject sessions, and this we need to manage this really well. And then we're going to have, of course, recommendations. And so we are really keen on to interact with your projects, and how can we would be very welcome. We would welcome ideas of how we can better bring lines of evidence together and characterize climate risks. And also this discussion of definitions would be welcome. And what new evidence do we expect from the Earth system models and TIPMIP? I think what we can do is we can recommend what to look for, and in terms of in comparison with other sources than modeling, but also how can we bring these together? Yeah, that's pretty much. That's our assessment paper, and I'm very keen on comments and recommendations. Should I stop sharing?
Thanks very much.
Can you still hear me? Oh boy.